modernization means like when you change something with the help of some artificial intelligence or some by seeing some of the disadvantages, you have come up with something like sustainable or use of renewable resources. That is something we call the modernization. So basically, what the effect of modernization has been seen on the thermal power plant is that it is like first one is improved turbine efficiency. Because of this modernization, it has improved the turbine efficiency. Like we have advances in the materials and designs which have improved the performance of a turbine. Then basically, we have integrated the renewable energy resources. We have started, incorporating with the renewable sources. Second is because of this modernization, we were able to reduce the emissions. Then we have used the automations and monitoring systems, which has improved the operations working in the thermal power plants. Secondly, which is very popular nowadays is you people have heard about the company that's TCS. He has made a digital twin technology by the use of artificial intelligence, which has basically reduced the performance and the cost of the power plants. And the last one is emission reductions. Because of the desulfurization and selective catalytic reductions, we have cut down the carbon dioxide emissions. So first of all, coming to the what is the effect of digitalization, like you can see on my slide, which is on the screen. I have listed 4 points that what is the effect of power plants on the modernization. First one is we have digitalization and AI integrations. Then we have smart grids. Then we have renewable energy and sustainability. Then last one, we have efficiency and cost reductions. So how digitalization has improved the efficiency of thermal power plants? First one is the most important is we can say the digital twin technology, as I was talking prior, that how the TCS has given the animation videos and has implemented in the power plants their digital twin technologies. Basically, this helps us to predict kind of performance and optimization operations, which of the virtual models of the power plants. And these models do also help the carbon dioxide emissions up to gigatons globally, which has been released in the magazine. And second main one is smart monitoring and IoT integrations. Basically, sensors and IoT devices, as you know, that continuously monitoring equipments that used to detect faults before the failure occurs. So this is very important. Like suppose if we are well aware of the such things that in the power plants, there are very sensitive equipments. So we can't wait for them to, get the failures done. So we need some devices which prior tell us that or prior detect the faults, right? So that's why we need smart monitoring and IoT integration is done. Then you can see that because of the smart monitoring and IoT integrations, the predictable maintenance has reduced 20 to 30%, which has improved the reliability. And then we can talk about artificial intelligence and data analysis for optimizations. Then you can go with any remote operations, like you can say that automatic control systems that do allow remote monitoring and operations, which has reduced the human error. And digitalization has basically enabled the flexible load management, which let us adapt to the fluctuations in renewable energy supply. So this was all how that digitalization has helped us. And the next slide is Now the question comes that, okay, we can digitalize the things in the thermal power plant, but what kind of challenges we are facing, right? So first and very important one is cyber security risk, right? So this is very important, as you know that all the if like as power plants become more connected, they are increasingly vulnerable to the cyber attacks. So protecting critical infrastructure from hacking or data breaches is our major concern, right? And second one is high cost of infrastructure updates. Obviously, when you go for the technologies, when you go for the new equipments, rather than the layman equipments, so you need a high cost. They like, because those digital solutions do require significant investment in the technologies and equipments. So many older plants do struggle with the financial burdens of modernization also. What this statement means is that you can see in India, there are many in the thermal plants, there are many such thermal plants which has not totally shifted to the modernization just because of the cost issues and all the things. And the third point is data privacy and regulatory compliance. That means handling vast amount of operational data. It required strict compliance with the, like we can say privacy regulations. So, ensuring transparency while maintaining security, both the things make the a kind of complex challenge for us. Then fourth one is workforce challenge and skip gaps. It means that the people, those who are right now working in thermal power plants, they are not specialized, or they are not having that knowledge of AI, IoT, or data analysis. So we do have some workforce talent challenges, as you know that I myself is teaching in some college. So there also we are not, as an electrical engineers, to be worked in the power plants. We don't let them teach artificial intelligence or IoT things. We are still at the same things, like we are teaching them how the motor is working, how the turbines are going to move. But, that's the problem, that workforce challenges there. Next is there may be some kind of difficulties in training the employees which are currently now working there, or hired some skilled professionals. Then fifth one is integrations with existing system. That means legacy systems may not be comfortable, we can say, with the modern digital solutions. So it's very difficult for upgrading the infrastructure while maintaining the operational efficiency. So, kind of this. And the last one is market and operational challenges. This means that sometime power plants must adapt to the fluctuating energy demands, and, changes in the regulatory things. So digitalization can improve efficiency, but it requires some, plannings and executions in a very careful manner. How a smart grid and automation has changed the thermal power plant. So basically, first is real-time monitoring and predictive maintenances, like that IoT sensors can continuously track plant performances, or it can detect faults before they can accelerate, right? And moreover, artificial intelligence driven predictive maintenances may reduce your downtime and repair costs as well. So second is like grid stability and load balancing, if we talk about this. So smart grids enable, you can say, dynamic load adjustments that ensure optimal power distributions through, across the area. Automatic systems may help thermal power plants to integrate with the renewable energy resources, which may balance your fluctuations as well. And then the third one is efficiency and cost reduction. So automatic control system we are using, they may optimize your fuel combustions, improving the thermal efficiency. Then AI powered analysis reduced basically operational costs by minimizing, you can say, a kind of energy waste. And the fourth one is emission control and sustainability. Smart grid automation enhances, carbon technologies or carbon capture technologies through which we can reduce the emission of carbon dioxide. And this artificial intelligence monitoring can help us with the environmental regulations also, so that we can ensure the compliance with what the regulations government has issued regarding the environment, right? And the last one is it's like very famous one, like cyber security. I've mentioned prior also. Cyber security and reliability is very important because smart grid used advanced interruptions, so we can do protect against cyber threats. So automatical fault reductions may improve your grid resilience by preventing the blackouts. So that's why we can say that it do have a reliable solution. Coming to the next slide, please. So now we will be discussing that what the power plant faces, what challenges if we do implement smart grid technologies or automation system. First one is that cyber security risk. Obviously, because of that connectivity, we are making the power plants more vulnerable to the cyber attacks. And protecting critical infrastructure that do require some security protocols and interruptions which are advanced. And second one is integration with legacy system. So basically, as I have told prior as well, that many power plants still use outdated equipments that is difficult to integrate with the modern automation. So upgrading infrastructure do require significant investment and technical expertise, that the same challenges which we have faced during the digitalization, right? And then we have data management and processing, like smart grid do generate vast amounts of data, requiring efficient storage and analysis. And artificial driven analysis do help, but managing real-time data remains still a challenge because it's difficult to maintain the real-time data. Then we have reliability and stability issues. Like you can say that automatic systems they must ensure grid stability, especially with fluctuating renewable energy resources. And artificial intelligence based solutions may improve efficiency, but they do require the continuous monitoring as well. And the last one is the regulatory and compliance challenges. So it's like one of the panelists prior already mentioned that the government imposed strict regulations on automations and smart grid, implementation. So compliance with environmental and operational standards do add some complexity in the things. You can say that renewable energy and sustainability have some significantly influenced thermal power plants. Like, what are the challenges we can see? First one is shift towards cleaner energy sources. So, here we are going to discuss that what is impact, like if we are using renewable energy and sustainable, so what the impacts you can see on the plants. First one is very understandable in its words only, that it shifts towards the cleaner energy sources, because if you are integrating or you are using renewable energy sources like solar or wind, that obviously you're reducing the use of fossil fuels, as one of the panelists was talking about the outer energy, and one of the sir who was just telling, giving the lecture prior to me, he was talking about solar thermal as well. So second one is hybrid systems combining this thermals and renewable improve energy stability. That's I've already told. Then second is reduction is carbon emissions. Obviously, if you're not using fossil fuels, you are preferring to some renewable resources. So you are reducing the carbon emissions and you're going towards the cleaner technologies. Then improved efficiency and flexibility. Obviously, energy, because of this advanced energy management systems, you can optimize consumption of your fuel and may reduce the waste as well. So you can say that thermal power plants are adapting to fluctuating renewable energy inputs and improving grid stability as well. Then policy and investment shifts. So government and investors are prioritizing renewable energy projects because just to so that they can improve the working and kind of to meet the sustainability goals. And then last one is challenges and adaptations. Thermal plants faced integration challenges with the renewable due to intermittent energy supplies, you may say, and innovations in energy storage and smart grid technology do help balance demand and supply. What are the challenges we are going to face that if we are going to implement this renewable energy and sustainable initiatives? So first one is intermittency and reliability issues. Like renewable sources like solar, wind, they are weather dependent, okay, so you making energy supply inconsistent. And second most important is that energy storage solutions such as batteries, they are quite expensive and still evolving. And second one is you can say high initial investment cost because transitions to the renewable energy required some significant capital, for upgradations of the infrastructure. And many plants, as I've told, still struggle to secure the fundings for sustainable projects. And the third one is grid integration challenges. It's like the power grids which are already existing, they are designs for fossil fuel based energy, right? So making integrations to the renewable may be a little complex, and the smart grid technology is needed to balance supply and demand efficiency. And last is second last, I mean, policy and regulatory barriers. Again, government impose strict regulations. They vary by reason to reasons, completing implementation. So it's not like that you make some rule for a particular state, but it don't implement to the other states. So sometimes policies and regulatory barriers do had a problem. And the last one is technological limitations. Like, you can say advancements in energy storage and efficiency are needed to make renewable more viable. And there are still many renewable technologies which are still not developed because we people have not, you know, it's not, I have mentioned this wording because, we are not totally shifted to the renewable resources. That's why we can't say that we have made all the technologies which are, good or had 100% giving the output in renewable technology.